Welcome to the lecture on interfacing I/O devices with the 8085 microprocessor. Microprocessor communicates to the external world through I/O devices. Some of the input devices are keyboard, switch, analog to digital converter, and output devices LED, sound segment, LED display, printer, etc. The key points how we are connecting microprocessor and I/O devices. Know that microprocessor will be operating at high frequency and your I/O devices will be operating at a low frequency. To connect this high frequency microprocessor and low frequency I/O devices, there is a junction or a medium. It is called as a port. To interface this, we need I/O ports. That is generally called as ports. You know that the general meaning of port. What is port? A junction which is connected as it will act as a junction where different modes of transportation will be occurring. Example is airport or seaport. The same way for microprocessor, I/O port is nothing else, is simply a latch or a buffer. So this is the basic block diagram explaining how I/O devices is connected to the microprocessor. How they are connecting is nothing else through I/O ports. Here we have an input device and output devices. Your input device is DIP switch and output devices is LED. DIP switch is nothing else, dual inline package switches, and LED light emitting diodes. Now microprocessor and your input devices, that is your switch, is connected through a port, that is input port. Input port is nothing else, simply a buffer. It is called as a buffer. A buffer. What you have to do is to read the data from any input devices. Microprocessor will be reading the data from the input port. How it will be doing is, we need to select a I/O address or corresponding device, that is dual inline package. How we are performing is through the address bus. We need to decode this address and select the corresponding input port. And next we need to generate a control signal. Microprocessor will generate a control signal, that is read control signal, and this read control signal will enable this input port. Now whatever the data available at the dual inline package will be stored in the input port and it will be moved to the through data bus to the microprocessor. The same way for writing to the output port. Output port is nothing else, your simple latch. It's a latch. Whatever the data, the same thing, we need to decode the address. Corresponding output devices should be selected through this signal and control signal should be generated and it will enable the output port, that is the latch, and your data will be returned back or write to the LED. This is the how an I/O devices, the basic block diagram. Now we need to know what are the steps, the step-by-step procedure, how a microprocessor will be connecting to the I/O devices. What you have to do is, the first step is you have to decode the address bus so that you can generate a device address pulse or I/O address pulse. The other name or I/O address pulse. The device address pulse should be generated through the address bus what we have sent from the microprocessor. Now this address pulse should be combined with the control signal, whether it may be read control signal or write control signal generated from the microprocessor. We have to combine these two signals, that is AND gate performance, and to generate another signal that is called device select pulse. Using this device select pulse, what you have to do is, this I/O port will be activated. This device select pulse will be used for activating the IO port. The same what we have studied in the think pair share activity, that interfacing with the memory, we need three steps, that is chip select signal and control signal, memory read control signal or memory write control signal. Following that we will get a data on the data bus. The same thing, we need a three steps followed for interfacing with the IO devices. See the basic block diagram of interfacing with the 8080 microprocessor. See how we will be performing what we have studied in the previous slide. The same thing is explained in the diagrammatic fashion. See, we have address lines, that is from microprocessor. This address lines is connected to the decoder. Through decoder, we will generate a device or IO address pulse. That is device address pulse or IO address pulse. This pulse will be connected with the control signal. That is the microprocessor what we have written, IO read signal, IO write signal. Combined with these two signals, that is device IO address pulse, IO address control signal, we will get another signal that is called as device select pulse. This is for enabling the latch or tri-state buffer. If it is an input port, it will be tri-state buffer. If it is an output port, it will be latch. And your microprocessor data bus will be connected to this latch or a buffer. And our other side of the buffer will be connected to the peripherals, that is your input devices or output devices. What happens? The same thing. We will get the signal from address lines, decode it. We will get a device IO pulse combined with the IO read control signal. We will get a device select pulse. Combine this, when we are enabling the latch or tri-state buffer, whatever the data is available from the peripherals, either it will be moved to the data bus. If it is a tri-state buffer, it will be acting as a input port. If it is a output devices, the data bus what is available will be moved to the peripheral and it will be a latch. This is the basic block diagram. The next one, addressing schemes, IO addressing schemes. There are two addressing schemes, that is memory mapped IO, peripheral mapped IO or IO mapped IO. In memory mapped IO, what you will be doing is this IO address decoding circuit will be used and your IO devices will be used for connecting that memory location. That means 8085 microprocessor has 16 address lines. That means 64 kilobytes of memory locations can be addressed. And any one of this address can be used for connecting to the IO devices. For example, we can have a number that is 0123H. This address is used for connecting an DAP switch. Assuming that we are example, any one address space, that is 64 kilobytes of memory location, we can choose any one memory locations for connecting to the address space. That is called as memory mapped IO. What we will be doing is we can directly, or that IO devices will be assessed as a simple memory locations. That means we can use memory related instruction, that is LXI, move immediate, or moving the data, copying the data from memory. What we will be doing is whenever we are using that instruction, that will be acting as a memory location. In peripheral mapped IO, what we will be doing is we'll have an IO address space, that is we can connect up to 256 IO memory mapped addresses. That is 8 address lines are used for addressing the peripheral mapped IO. That is 2 power 8, you will get 256 memory locations or 256 address space are used for peripheral map. This is where using, we have 16-bit address lines, but you will be using only the 8 address lines. either lower byte or higher byte. We will be using that. And here it is, to interface or read the data from IO devices, we will be using in-out instructions. And example for connecting 7-segment LED display, what you have to do is, your peripherals will be connected here, and your data, whenever data, what you have to do is, address lines correspondingly which address we are connecting this 7-segment LED display will be generated through this address lines. Whenever address lines are given, your address bus will be given here, and you will be generating device address IO pulse, and from the control signal combined with that you will get device and X signal, and it will be enabling the latch, and you will get the corresponding whatever the data you are going to write will be returned to the display. Thank you.